Okay. So, good afternoon, everyone, and welcome to this QMEA webinar this afternoon. So my name is Jen Hoyle, and this afternoon we are joined by Lauren Hammond from Glencore. She is based at the Hale Creek open cut mine, and she's going to be talking to us today about chemistry in mining. So, as you would know, just sharing my screen. So as you would know, at QMEA, we spend a lot of our time travelling around Queensland, visiting different schools and delivering face-to-face sessions. Now, obviously, with COVID, that's something that hasn't been able to be done. So as a result, we've come up with these series of webinars that allow us to still engage students with industry representatives and hear about different parts of the resources sector. Whilst we're waiting to be able to go back out into schools. So as I mentioned this afternoon, we are lucky enough to be joined by Lauren Hammond from Hale Creek, and this afternoon Lauren's going to talk to us a little bit about her role as a process engineer and the role that chemistry plays in her job and why it's important in the resources sector. So I'm going to hand over to Lauren now to tell us a bit about herself and about her role. And if you have any questions throughout this session, make sure you place those questions into the chat box. I will moderate those questions and put those questions to Lauren, and she can respond. Okay. So over to you, Lauren.
Hey everyone. I've put together a little bit of a presentation because I feel like it's probably going to be the easiest thing to talk to you about. Let me just get that up. Share that. So it's not a very long one. I haven't been in the industry very long. This is my 3rd year in mining. I actually visited Collinsville last year before I left Glencore Collinsville site and did something with QMEA there, so some of you may or may not have seen me before. So I'll just get started. So how I became a process engineer. Basically, just like you, went to high school. I grew up in Townsville, so I went to high school in Townsville. These are the subjects I did in grade 11 and grade 12. I did chemistry, physics, maths B, maths C, accounting, and English. At that point in time, I didn't really know what I wanted to do. I was tossing up a lot of these like mathematical I thought accountant, but really the only thing that made a lot of sense to me was engineering. Didn't have any idea what sort of engineering. Engineering is quite good in a way that the first year of your degree at university, you can just do like a broad course. So you do little segments of each different type of engineering that they offer. And at the end of that first year, you can decide, okay, I really liked this section of engineering, and so I'm going to go with that one. So at the end of my year, I decided, okay, I really like chemical engineering, so what I decided to do. So at James Cook University, again in Townsville, I studied chemical engineering and minored in sustainability. I put a few little things there as well. I felt it was really helpful to do extracurricular activities to assist with getting a job and basically expand your understanding of how you're going to fit into the workplace. So I applied for and got the scholarship for women in engineering for the whole 4 years of my degree. I was involved in the JCU Engineering Undergraduate Society for 3 of the 4 years, and I was also the JCU Engineering Ambassador for, I think, the last 2 years of my degree. Process engineering in Glencore. I'll give you a quick little rundown of how I got here. So the Glencore graduate program is a 2-year commitment. However, I was pretty lucky. I started in Collinsville in February 2018 as in the graduate program. But pretty quickly after that, in October, the full-time engineer at Collinsville decided to move on. So I was allowed to take over as acting process engineer, which basically just meant I was the process engineer, but I was just acting because they couldn't give me that full title. And then in April 2019, I took on the full-time process engineer role at a bit annoying because I didn't get that 2-year safety net that you get from a graduate program, but it was something that I think was really beneficial for me because I'm someone who learns pretty quickly by being chucked just straight in the deep end. So that was quite good. As for my actual job, what I do, I've put a few little dot points here of some of the day-to-day tasks that I get up to. So I do day-to-day monitoring of plant performance to ensure coal is within spec for shipping. Both that involves me both being in the plant taking manual checks and at my desk looking at these trends. So this little picture on the side here is the trends that I would look at on a day-to-day basis. There's probably about 100 of these little graphs that I scroll through probably 30 times a day. Just quick look over. It's pretty easy to see where things are wrong when you know what you're looking at. I also do a lot of sampling and analysis. So basically going out into the plant and sampling around a piece of equipment, feed product reject, and then sending that data or that coal away and getting analysed. And the data we get back is then basically put through some sort of template or model, and it spits out the information that I want to see. And then another component of my job is to implement projects that improve efficiency of the process. So process engineers basically look at the process that they're involved with, and we just want to make it as efficient as possible. So that's quite a large part of my job too. Oh, and that's me after sampling completely covered in coal. So one of the questions that Jen asked me to answer was what chemistry is involved in process engineering. And the one thing that I hear a lot when I say I'm a process engineer or I'm a chemical engineer is that they don't really know what it means to be a chemical or a process engineer and what the difference between those two things are. So in summary, the same thing. Basically, at university, you would study chemical engineering, but generally when you go into the job market, you don't get hired as a chemical engineer, you get hired as a process engineer. This is just because chemical engineers don't deal specifically with chemicals like you would assume a chemist would. Like, we don't go out there and put things in beakers and look at various reactions like that. We are generally in charge of looking at a large scale picture of a plant, which may or may not involve chemical processes. So we definitely require knowledge of chemical processes and chemical properties of things, but we don't really need to be as knowledgeable about every single chemical reaction that could happen like a chemist might. So yeah, like I said, a large majority of my job is improving efficiency of a process. So seeing an overall process, like this one on the side here, and understanding where the inefficiencies lie and fixing them. So as for chemistry and mining, what do we deal with? We deal with the surface chemistry of coal, hydrophobicity, and those sorts of properties that make the mixture of coal and water possible and we need to understand chemicals, understand the chemicals that we're adding to the process and how they help us separate coal from rock. And we need to understand if adding specific chemicals into a process that already has chemicals in it are going to cause reactions and what that would mean to our process. Coagulation and flocculant of water is a really big one and probably one of the most used chemical processes. And we also need to know the metallurgical and coking properties of our coal. How quick is a coking coal mine. So Collinsville coal mine is a thermal mine. So basically their coal is used to power power plants, whereas coking coal is used to create steel. So just another little back bit here. This little picture on the side here shows you sort of what coagulant and flocculant do. Super important in a lot of chemical industries because it allows us to separate suspended solids from water, and it lets us recycle that water. So wastewater systems, mining, pretty much anything that involves mixing things with water, you would do a coagulant and flocculant process to separate the water so you use it. So this is a little slide in here basically showing you the sort of mindset thought process I would go through to solve a problem in my job. So basically what we do is we go out and we find a problem, or we have an idea that might help our plant. So example is we've decided our yield in the flotation circuit is just way too low. We're not getting enough product out, all of it's going to reject, it's not great. So the first step we do is we generally brainstorm. I'm in a team of three process engineers total, so we generally sit down and have a chat and talk through, okay, what could be causing this low yield? What could we do to bring the yield up? Is it something else that's affecting the process, or is it actually in this system? Is it coal dependent, or is it based on the chemicals that we're using? Those sorts of things. And so out of all that brainstorming, we come up with our hypothesis to test, to decide if we can fix that problem. So, for example, our hypothesis for this situation would be to modify chemical dose rates into the flotation to helpfully assist in recovering coal and increase the yield. So the next step is to develop a sampling plan to address fixing the problem. So an example of this is we would sample the flotation circuit, feed in the product that would get and the reject out, so we can get an overall view of that whole circuit. And we would do these samples at different dose rates. So we might start with a low diesel dose and then go high, medium, low on another chemical, and then we might go to a medium diesel dose and go high, medium, low on another chemical, and then high on the last diesel dose, high, medium, low on the other chemical. So it's a little bit, you have to gather a lot of samples and it's very time consuming, but doing this very comprehensive sampling plan allows you to get the most comprehensive amount of information you can get, and basically means you don't have to go back and sample later, which is a big pain, really. So once we've taken those samples, we send them away to an off-site lab, generally SGS or B in Mackay, and we can ask for a whole bunch of tests to be conducted on these samples, but generally we just do the percent ash in each sample and the percent solids in each sample. And from these two things, we can determine yields, we can determine if we're sending material the wrong way, lots of stuff. So once those results come back from BV, we usually put them in a spreadsheet or put them through Excel and do some calculations on those numbers. It's really easy to see. And then once we have these results, we can either confirm or deny our hypothesis. And if it's correct, if we've decided, yep, this change we've made is actually beneficial, we'll then change the operation of the CHPP. So this is a little one that we did earlier in the year here, and it just shows you our yield, which is what that whole example I was just talking about, does when we change one of our chemicals, which is MIBC. So the blue one is one coal type and the orange line is another coal type. And down the bottom, you can see your MIBC dose rates. I'm not sure if you can see my mouse, but down the bottom, you can see my MIBC dose rates. And along the side, you can see the yield percent that we get. So Basically along here you can see in this green circle, at that point we're dosing 20 litres per hour of MIBC, and we've sort of maxed out that yield. If we add more MIBC to the system, we don't really get any more benefit, and it's just costing us more money because adding chemicals costs money. So this is our ideal set point for MIBC. And so previously we were running probably 15 litres per hour without any test work. And so by increasing to 20, we've increased our yield by about 10%. And that's really beneficial to our production. Gains us heaps of money. So that's pretty much it. That's the general process I use to go about tasks or issues I see in the wash plant. And that pretty much concludes the information that Jen wanted me to cover. So, yeah.
That's brilliant. Thank you so much, Lauren. So I've got a couple of questions that I've got for Lauren. But if you have any questions, make sure you pop them in the chat box so that I can put them to Lauren for her to answer. So I just wanted to sort of reiterate that process that Lauren was talking about, doing multiple tests, taking the results, looking at the results, going back, maybe updating your process. That's a perfect example of what you guys will probably be doing in your experiments. So it's something that all scientists do, regardless of their speciality or regardless of the industry that they work in, that they take the results they get from their processes and look at those results, see how they can improve them, or if they can be improved, and use that information to make things or make process better. So that's an excellent example. So thank you for sharing that, Lauren. Now, Lauren, you did mention the difference between the two types of coal. So you mentioned there's metallurgical or coking coal, which is what you use at Hale Creek, but then there's also the thermal coal. Are you able to just sort of elaborate a little bit more on the chemical differences between those two types of coal and what makes them different and why they're used for different purposes?
I actually don't have a great understanding of this one. I've never really had to deal with it too much. It's more of a what the geologists do, but I can give you a very basic understanding from what I've learned. Basically, coking coal is a lot softer than our metallurgical coal, and it has more desirable properties that allow it to melt in a coking furnace and be transferred into a steel production. Whereas thermal coal is this really hard sort of rock, and it has a lot of energy in it, but that energy can't be used to create a different mineral, I guess. It can only be used to convert that energy into thermal energy, which is used to power a thermal plant. So that's my very basic understanding of the difference there, sorry.
No, that's all good. I might just get you to stop sharing your screen just so the students can see your face a little bit better. So essentially, my understanding of it is that thermal coal is a lower quality than metallurgical coal. Yeah.
Generally has a higher ash content, which means there's a larger percentage of rock or stuff that can't be converted to energy.
You're just breaking up there a little bit. Lauren, can you hear me now?
Oh, sorry.
No, it's not you. It's your connection. It's all good. Excellent. All right. So, what, like you said, you were considering lots of different career pathways, and when you studied engineering, what was it that made you go down the sort of chemical engineering pathway as opposed to, some of the other types of disciplines?
This is really interesting, actually, because I'm usually someone that makes a decision pretty what I'm going to do. when I got to the choice of what engineering I wanted to do, I was really divided over if I wanted to do civil engineering or chemical engineering. Civil engineering is the one you think about every time you hear the word engineering. It's buildings, it's bridges, it's creating structural integrity. And I really liked that idea leaving high school. But when I got into university, we did a lot of, obviously that first year, like I said, was broken up into all the different types of engineerings. I know I didn't like mechanical. It was too many gears and moving parts. I knew I didn't like electrical. That just did not fit in my brain. I couldn't understand it. But chemical was really fun. All the other engineering types, they seem really rigid and really solid, and there's a set process that you have to follow, and that's how you get your answer. Chemical engineering is great because you can do a thing 1,000 different ways and get 1,000 different answers from it. And I just really liked that there was a lot of different solutions to one problem and that any of them could work, and you had to sort of fight for why your reason was the reason, or your solution was the solution that should be used. And that was enjoyable to me.
Yes, there's not as many rules that
Yes.
to follow.
Yes,
There's
exactly.
not just a black and white answer, so to speak.
Yeah, it's a very, very broad field, so you can pretty much slot yourself into any job very loosely. And yeah, you can really you take on a lot of components of other types of engineering as well. Like I take on a lot of mechanical engineering roles because I do a lot of pumps, and I deal with control systems, which is electrical engineering as well. So yeah, it's pretty cool. It's sort of like this weird middle child of the engineering world.
Yeah, not many people know about chemical engineering. So yeah, it is sort of one of those forgotten disciplines of engineering, isn't it?
Yeah, definitely. You can tell anyone you do anything and they just believe you.
That's right. So in your, just thinking about like your day-to-day type of role, what are some skills other than obviously the technical skills that you feel are really handy and useful in your role?
I know the biggest one people struggle with as the engineering sort, if you're going to put engineers in general into a hat, it's that they don't have a lot of communication skills. They usually are really, really smart, technically minded, whizzes at computers, but when it comes to telling an operator they need to change something or explaining why they need to make this change that's going to give the company so much more money, they freeze up and they're not really good at it. So I think one of the big things is being able to express your solutions, your ideas in a way that's accepted by everyone. So you can't just be very arrogant about your answer. You've got to present it in a nice way, but also being confident in the way that you present it and being confident in what you're really presenting as well. You've got to believe that your solution is correct and is right and will save the company all of this money. So I think that's really important.
Yeah, no, I agree. And also, you mentioned before that you work in a team as well. It's not just you. So obviously, communication skills and teamwork skills are a really big part of your role.
Definitely. And I think doing like all the extracurricular activities I did in university and high school really helped me to build those skills up more than maybe some people had.
Mm. And again, looking at sort of a day in the life of Lauren, how would you explain what you do on a day-to-day basis?
Yeah, it's pretty cool out here because there's not really a standard day. It's pretty cool because you can come in and after the weekend, you've left the operators by themselves, the plant's operating, and then something happens in the middle of the night. A rock gets stuck somewhere, something fails, and you come in on Monday and everything is just gone wrong. Everything that you could think has gone wrong has gone wrong. And so my job in that situation is to go out there and help them fix it. So that's me getting out there hands-on, going, touching and feeling all the different things in the wash plant, helping them to change the settings, helping them to turn on and off valves, maybe even picking up a hose and hosing off a level that's full of just spillage. So that's a pretty cool part of my job. It's not something that I thought I would be doing, but I really, really enjoy it. And then there's also the part where I sit at my desk maybe for a whole day and I just look at spreadsheets and look through. I'll show you my screen for a second because there's one I've been working on that's a pretty fun look. This one here. Just let me know when you can see it.
Yeah.
So yeah, some of my work involves scrolling through endless amounts of data and just picking out those orange points and then trying to make trends out of them. So like this is some of the trends that I've found in that data, and then I've got to decide, okay, this is a trend, but what does that trend actually mean? So then I've got to explain what it means to someone that's looking at it. So if you guys right now looking at it, you've got absolutely no idea what it means. And so my boss usually looking at that has absolutely no idea what it means. So I've generally
Oh,
am I back?
we lost you. We lost you there. We lost you there for a sec. That's all right. So you were talking about having to break down those graphs and explain them in a really easy fashion so that, you know, any person is able to understand what those graphs are telling you.
Yeah, exactly. So I could be explaining those graphs to our operators. I could be explaining those graphs to my manager. I could be explaining those graphs to the SSE. So really, it's got to be understandable by anyone.
Yeah. No. And again, it comes back to the communication that you mentioned before.
Definitely.
So I actually have a really good question here from Collinsville. They've asked, what challenges have you faced as a female in this job? And also, too, I guess I might extend that question a little bit and say, and in the resources sector, if you've experienced any challenges.
Yeah, it was pretty eye-opening going to Collinsville in 2018. When I first started, I was 22. I'm not very tall, so I fresh face, brand new, and I was the only woman in my department. So that was think about what I was going into. I've been really lucky because all of the teams I've worked with have been really supportive of me and they've accepted me. I guess the problems I face the most are people trusting what I'm saying is correct or having credibility, really, because I'm young, I'm a female, so generally they get their directions from older males in the industry. And so when I come in and say, hey, can we change this setting in the wash plant, I sometimes get met with a bit of like, do you even know what you're doing? Do you know what you're talking about? But dealing with, which works really well with operators because we've got a set amount of operators and I deal with them all the time. So I won't just go into the control room and say, you need to change this setting and walk out. I'll go into the control room and ask about their weekend, ask if they want a cup of tea, come sit down for a little bit, and then be like, oh, look, I noticed this in the wash plant. Like, I had some thoughts on how we can fix that. Can we work through them? And so it's more of a combined approach of me sitting there and working with them to work through. Overall, it builds your credibility. So if I don't have time one day, I can just go in there and say, hey, I need this changed. And they'll be like, oh yeah, she knows what she's talking about because we sat together and talked through this last time. So.
I think we've lost you a little bit again. Oh,
I'm so sorry about this bad connection.
No. Maybe we might just try if you just try turning your camera off. Maybe that sometimes helps with the connection. It's not as fun,
right,
but it might help. Might help a little bit.
Just imagine my face.
Exactly. We know what you look like, so it's all good. So another question I have is how are you how is technology used in your role, and what sort of changes do you envisage occurring into the future? We know the technology is evolving at a great rate, and what sort of impact do you think that's going to have on what you do?
Technology is amazing. Even just since I started that installed and implemented maybe 20 or 30 years ago, whereas Howell Creek was only actually installed, what's the word there, designed, created, constructed in 2007. So it's much newer, and it's got all of these new technologies that have integrated in it. And so that's only a probably 20-year difference in the wash plants, but significantly more automation and control at Howell Creek versus Collinsville. And now report managing and automation of a lot of tasks, it is just going to blow up in the future. So I'm working on a thing at the moment where I basically automate my entire end of month reporting, which usually takes me 2 days of solid work to get all the data together. And this new method will take about 10 minutes and 1 button click. So
Wow,
it's that sort of stuff where, isn't it? I know. Yeah, it's that sort of stuff which I love, because process efficiency, right? It's
exactly, that's right. And I guess it changes.
Change. So.
Oh, sorry, I didn't mean to talk over you. I was just going to say, I guess it changes too with that sort of automation piece. It's a lot of data analysis and looking at the data that's coming out, as opposed to actually physically going and collecting the data. So it gives you more time for that analytical type of piece.
Yes, I definitely agree. Although it is really good I need to go out to the plane, go for a walk, because you get so sucked up in looking at data, and sometimes you just need to see it to understand it. So sometimes going forward is definitely always going forward is great, but sometimes you see.
Oh, we've lost you again. Are you able to hear me, Lauren?
Yeah, I can hear you.
Do you hear me? Okay. All right. Well, I've just got a couple more questions from Collinsville, so we might get through those. So the next question is, have you ever made a mistake, and what happened at the plant? No, looks like we've. All right, you're back.
Sorry, I lost you there for a second. Yes, I'm back.
Yes. Okay. So the question was, have you ever made a mistake, and what happened at the plant because of that mistake?
Oh, definitely. I think you're not really allowed to make any more choices unless you make a mistake somewhere, right? A lot of my role is trial and error, so I've got to let's change this valve position to this number, let's change this time, and just see what happens, because of cleaning up, I've blocked it's all just sort of accepted what you need to do to make things better. The operators are not huge fans when I do that, and you do have to say you'll help with the cleanup, but yeah, it is just part of the job. You really do have to push it.
I think we've lost you again there, Lauren. But I think from what I can gather, it was if you do make a mistake, you have to help clean up. that's the message I'm getting there. Lauren, your connection is getting pretty patchy, so I do have a few other questions from Collinsville, but I might actually put them in an email to you, and I might get you to answer them over email, and then we can send those to the students once you've answered them over email. It might be the easiest way. So that we're sort of getting to the end of our session. That concludes our webinar this afternoon. So I just wanted to say thank you so much to Lauren for joining us this afternoon and imparting her knowledge and advice about process engineering and chemical engineering. I found it exceptionally interesting. So thank you very, very much. And as I mentioned, those questions that I do have that I haven't been able to ask, I'll put those in an email to Lauren, and I'll send those off to you guys out there at Collinsville to get the answers. So before I go, I just wanted to say thank you very much to Collinsville for joining us this afternoon. And if you do have any other sort of questions or you want to learn more about the resources sector, there are many ways that you can go about it. So at QMEA, we have a Facebook page, we have an Instagram account, we also have a web page. So those are just a few places that you can go to learn more about the industry and some opportunities in the industry. And you can also head along to our awesome resources website. So it's ORESOME, awesome resources. If you head along there, there are actually a suite of videos that you can look at all about careers in the resources sector. So listening to people like Lauren talk about their roles and what they do and how they got to where they are. And also there are a whole range of resources connected to every part of the resources sector. So you can just go and check those out if you just want to learn more about what we do in the resources sector. So I'll leave us there for this afternoon. Thank you again, everyone, for joining us. This is recorded, so I will send the link out so that if you want to watch it again or pass it on to other people to listen to, feel free to do that. All right, thank you, everyone, and hopefully we'll be out at Collinsville soon doing some more face-to-face activities. All right, enjoy your afternoon, and we'll see you all soon. Bye.